Hello everyone, welcome to my YouTube channel. In this video, let's start focusing on one of the easiest leet code problem, that is contains duplicate. So let's understand the question. Here, given an integer array nums, return true if any value appear at least twice in the array, and return false if every element is distinct. So here the question is very straightforward. What they are saying is they are giving us a nums, an integer array. Okay, now we need to return true if the array contains any repetitive or a duplicate elements simply, and we need to return false if there aren't any duplicates. Clear? Now let's understand how we can be able to approach this problem. So we are solving contains duplicate, right? So here they gave us nums which is equal to, let us consider 1 2 3 4 and 1. Okay, this is my nums. Now I need to check is there any duplicate or not, right? Here we can say that there is a duplicate, right? But in terms of coding, how we can be able to approach this problem? So there will be a different solutions that we can be able to solve. uh, Out of that, one particular brute force approach I can be able to think of is, let's say if I consider one, I need to check in the I need to check that is there any other one in the array, right? In the other elements, in every other elements, I need to check is there any element that is equal to 1 or not, right? That means for every element I need to check the other elements in the array to know that there is a duplicate or not. So here I consider 1 and I am checking 1 with 2, 1 with 3, 1 with 4, 1 with 1. So 1 with 1. Now I find there is a duplicate, then I can return that there is a duplicate. So that's why I need to return true. But here with the first element I can be able to solve, right? How about if it's like something 1 2 3, let's say 4 4. Now how I can be able to approach? I'll start with 1. I will check other element 1 with 2, 1 with 3, 1 with 4, 1 with 4. No element satisfies is equal to 1, right? So now it will shift to the next element, that means 2. 2 will check all the remaining other elements, right? In 3 4 4, it's check whether is there any element similar, and with 3 also same, it will check the other elements, and with the 4 then it will check the element beside it. That means, so for every element we need to check other elements, and we need to repeat the process till the end if the element is present at the last. We don't know, right, where it will be. So here the time complexity that we can be able to get is like order of n square, because here we do need to require two for loops, right? One is like outer for loop which takes individual values, like let's say here the 1, and the second for loop it will take in, second is like inner for loop, and it will be taken care starting with I plus 1, and it will check till the n. Okay, so this is one of the approach I can be able to think of. And when we observe the time complexity is order of n square, which is pretty expensive, right? So think in such a way that can we be able to optimize this. So there is an order of n square time complexity solution. So now I do need to optimize this. So Let's say in a second optimization, I can think of something like about sorting. Say if we sort the array, let's say the first example only, 1 2 3, sorry, 1 2 3 4 and 4, right? So if we sort, this is already sorted, right? So for sorting, how much, what's the time complexity? It's order of n log n, right? And I will check, I will start with the first element, I will check the next element. So at every point, I can assume that if I check the next element, I can be able to find whether there is a duplicate of this particular element or not, right? If I found nothing, no duplicate, then this element won't exist in any other part of the array, right? So that's where we will check every element, so that, and we'll check the next element. If the next element is same as the previous element, right, then there exists a duplicate and we need to return false. Clear? This is one of the approach, but compared to order of n square, order of n log n is quite fine, right? Order of n log n with say for, and also after that we are checking every element, right? That means we are going till n, order of n, nothing but simplifying it, it will be like order of n log n only. Clear? This is compared to brute force, it's fine, but can we be think in that way, that can we be able to optimize it even more, even further, right? There comes one of the most widely used data structure, which is like hash set. Why? So let's understand the problem again. So here, what we are trying to do, we are trying to check that there is a duplicates, right? We are checking whether that is there is a duplicate or not. So how about if I store element somewhere, right, to track that, and for every other element I need to check that that element is present in the stored uh, part or not. If it is already stored, then I can be able to return, right, return true, that there exists a duplicate. So for the storing purpose, I used a hash set. Why hash set? Because hash set won't store duplicates, right? Won't store duplicates. So here what should we do? Let's consider a hash set, and for every element, if I will check that the element is present in the hash set or not. If it is not present in the hash set, then I will add that element to the hash set. Okay? So check that the element is present in the hash set. Element is present in the hash set, in the hash set. And after checking, now what happened? So if I found the element, then I can be able to return true. If I didn't found any, then I will add that element into the hash set. Add element uh, into the hash set, right? So clear? What's the time and space complexity? When we look into the time and space complexity, time complexity would be order of n, because though hash set gets the output like with the order of one operation or order of one complexity, but we are just going iterating from first element to nth element, right? So that means the time complexity is order of n. Whereas space complexity, here we are using a hash set. That means other uh, something which is stored, right? Some extra space that we are consuming. So that is of also size with order of n, right? It also contains n elements. So time will be order of n and space will be order of n. So let's solve this optimized solution with the hash set. So I'm getting here now. So let's start with creating a hash set. Okay, there is a hash set, and here I'm store integer, and let's call it as a set. Okay, is equal to new hash set. Now I need to iterate, right? For, let's say, int n of nums. For every element of nums, I will check that if set dot contains that particular element or not, right? Set dot contains with n. So if that is present, I need to return true. Okay, if not, what I should do, I should add set dot add this n value. Clear? If I didn't found any, then I can be able to return false, right? Shall we run this? Cool, it's accepted and submit. Good. But observe, it beats only 34% of the people. So that means there are few people who like use different solutions. This is same. Let's check this ones also. Okay, right, same. Any new things? Oh, similar, kind, similar. This is a different one. So what they are doing? Let's go to this one. Here, for int I is equal to 1, I is okay. They are iterating nums, and first whatever the value that I got, that let's say it's 1. Okay, that is stored in key. Here he is stored in the key, and j is equal to I minus 1, nothing but 1 minus 1, nothing but 0. He took like, okay, he started from 1, so that means 2, and he at j is nothing but 0. Now while j is greater than or equal to 0, okay, and nums of j is greater than or equal to nums of k, is equal to q. Nums of j, that is 1, if it is greater than or equal to key, it's not, right? J plus 1 equal to key. Okay, let's try to solve this. I'm not sure. We'll try. Let's increase this font. Text color will be black, something. Oh. I'm sorry. Something. Okay, let it be. So what they gave us the nums, right? Okay, they gave us nums, which is equal to say 1 2 3 1. Okay, now here I am starting with a for loop. For I started here. Okay, for I is equal to 1. Okay, so in this, and k is equal to, key is equal to nums of I, nums of 1, which is equal to value 2, 0 1 2 3, right? And in so j is equal to I minus 1, which is equal to 0, while while condition j is greater than or equal to 0, condition true, and nums of j nothing but nums of 0, which is value 1, is greater than or equal to key is nothing but 2, right? 1 is greater than or equal to key, no, right? False. So it won't get inside and it come outside the loop, right? Now nums of j plus 1, nums of j means 0, 0 plus 1 is 1, 1 is equal to key. Okay, and then I'm iterating. So for I is equal to 2, now what happens? uh, I is equal to 2 and key is equal to nums of, okay, nums of 1 is equal to key, okay, let's try, and key is equal to what it is. So nums of so it's j, right? Okay, nums of I, nums of 2, which is equal to 3. Now int j is equal to I minus 1, nothing but 1. Now while j is greater than or equal to 0, yes it is, and nums of j is greater than or equal to key. Nums of j is nothing but nums of 1 is greater than or equal to 3. No, right? Why though? If nums of j is equal to key, nums of j plus 1 is equal to nums of j is it going one by one? I think I made a mistake somewhere. Okay, let's ask ChatGPT. Okay, ChatGPT. So let's give it this particular code. Debug this code. Insertion sort plus checking duplicates while inserting the idea. Okay, so it's 1 2 3. Initially I is equal to 1. Okay, so key is equal to 2 and j is equal to 0. Nums of false, nothing happens. Array is 1 2 3 1. Sorted part is 1 2. Now I is equal to 2, so key 3 1. Okay, 1 2 3 is the sorted part, so I is equal to 3, key is equal to 1, j 1 2 3. 1 2 3 1. Okay, first iteration it's like nums of 2 is equal to 3 and 3 is greater than is equal to 1. Okay, it's equal to key. Okay, it's nothing, no, it's false. So what happens? Array becomes 1 2 3 3, j minus minus, j is equal to 1. false. Okay. Okay. Hmm. Returns the right answer. Runs in order of n square in the worst case. Cool. Okay. I think you guys understand, right? I'm sorry. I might to recap my sorting techniques. I will make another videos on this sorting parts. So insertion sort. So this approach is actually with insertion sort and checking duplicates. So what he does is like for every element, right? So when you observe 1, 2, 3, 1, right? It will check 1 and 2. So 1 is less than 2, right? That means this 1 and 2 are sorted. Now they it will check the next two elements, so 2 and 3. 2 and 3, and he checks like 2 is less than 3, like and this is also sorted. So that means 2 comma 3 is sorted. Whereas the next element, right, when we observe 3 is greater than 1. So now what happens is like this pointer, whatever the j that we are targeting, this is I'll say. So this I'm decrementing this. So j. So I'm checking. So the other value. So check that this value is equal to this value. If not, then again it goes j minus minus and check the other value. So if both values are same, then it's return true, else it returning false. Clear? So that's why j condition, it goes till like j greater than or equal to 0. So this condition is must ensured. hmm. Okay guys, that's for today. Thank you.